Welcome to my projectbazaar.com. Let me discuss about the process energy efficient infrastructure sensor network for ad hoc cognitive radio network. Let me discuss about the abstract of the project. The amount of data traffic in cellular network has been increasing dramatically in the past few decades. To cope with the traffic increase, heterogeneous cellular network has been introduced to improve network performance by offloading traffic to access points with better link quality. The increase of energy consumption directly increases the greenhouse gas emission, which threatens the environment. Radio frequency, RF transfer and harvesting techniques have recently become alternative methods to power the next generation wireless networks. An energy efficient decision that considers the trade-off between energy consumption and continuous transmission needs to be taken as to whether to switch the channels. Proposed scheme divides the available channels into two groups and performs sensing on both simultaneously. That is, one group consisting of the operating channel alone is sensed using narrowband sensing by the sensor nodes, and the other group consisting of the remaining channels is sensed using wideband sensing by the SU. A vacant channel in the later group is selected as a backup channel. An energy efficient spectrum handoff scheme is developed for a sensor network assisted cognitive radio network where the SU or energy constrained nodes with an energy harvesting capability from the environment. In actual sensing process, select the nodes from active subset and while performing the scheduling process switch the active subset to sleep mode. The sensor nodes are performing sensing process based on the respective time duration. For using the PU activity, only few number of sensors are switched to active setup to sleep mode during the respective time slots. Finally, compare the proposed system with the existing approaches and analyze the network performance, end-to-end delay of the process and consumption of energy with respect to number of rounds. Let me discuss about the flow diagram for our process. Initially, the system model has been designed. In this system model, CR nodes and normal sensor nodes are deployed, and next the cluster formation has been performed. The mobile stations are deployed which are acting as a CR. Sensor nodes send the sensing result directly to the CR that serves as a cluster head. CR node sends the ADV message which contains the identification number of the CR, its position, the nodes registered to the CR and the header field. Within the nodes within RS from the CR respond to a join request message which consists of identification number of the nodes, the identification number of the destination CR, the energy state, node selected CR to join in order to reduce the energy consumption. If any one node having same distance the two or more CRs, then the smallest number of registered nodes to minimize the waiting time for sending the sensing result. And in the cluster updating stage, basically CR does not change the location during the time duration. Cluster updating process is performed when the number of registered nodes are changed and the location of the CR is changed. If a node receives the ADV message from new CR, it will change the cluster group only if the distance of the old CR is greater than the distance of the new CR. In this request, there are ill request message has been received, that is leave request message that contains node ID and CR ID which has to be sent to the old CR. Next, in the subset formation, cluster is divided into one or more distant subsets so that activating only one subsets of the nodes instead of activating that all the subsets in order to reduce the consumption of energy. Finally, the energy has been estimated. Total energy consumed by the sensor node can be decomposed as energy setup stage and also energy sensing stage. Finally, the energy sending stage. Energy consumed for the setup stage consists of the energy consumed in cluster formation, updating and subset formation. Finally, if the maximum round has been reached, then the process will be finalized. Otherwise, the process will be continued with the CR nodes to cluster member. Finally, the performance has been analyzed. Estimation of end-to-end delay, consumed energy, mean square error, and the probability of reductions has been estimated. Let me discuss about the name procedure for our process. Select the main.m file, the current folder, and run for executing this process. Here we perform the cognitive radio network with the energy efficient clustering protocol. Here we deploy the CR users and also the normal sensor users, and we analyze the energy consumption for our proposed system. This will take some time for execution because of keeping the maximum number of rounds. After executing the process, this is the our sensor nodes deployment and also CR users deployment. And this is the cluster formation. Based on the communication range, we form the cluster. Black color denotes the ideal node which does not form into any cluster. And this is the movement of CR users, and again we perform and analyze the clusters. And this is the performance analysis graph for our energy consumption by our proposed architecture in the setup stage, varying the number of rounds. This is the end-to-end delay response with the existing Sendora and LEC protocol with our proposed work by varying the number of rounds. And this is the consumed energy for our existing Sendora and LEC protocol with our proposed system. And this is the energy consumption for different communication ranges of the sensor nodes by varying the communication range. And this is the energy distance of the CR, mobility distance of the CR. By varying the mobility distance of the CR, we analyze the consumed energy with the help of existing and our proposed system. And this is the mean square error detection probability for our without subset, that is Sendora and LEC protocol, with our subset with maximum energy and subset sleep for NS slots. And this is the probability of detection without subsets, subset with maximum energy and subset sleep for NS slots. Finally, we analyze the energy consumption for our proposed system. Thank you.